So hi guys, good afternoon everyone. So I am a founder of Tech Scalable, a company which is into training and consulting in cloud and a few niche technologies like machine learning, AI, DevOps, and all. I've been working as an enterprise architect for 9 years, and in this IT industry, I have spent around 15 years of um the entire journey. I have done quite a few certifications in various cloud, and my forte is CI/CD. And these days, because Kubernetes is one of the trending technologies, I majorly work on Kubernetes and containerizing the application and moving them into the cloud environment and running them in Kubernetes. So my topic today as well is about how to monitor or manage the entire AKS cluster which we have. So I'll be showing you varied varieties of AKS clusters. I have set up 2 clusters. We will see how we can monitor our containers well with the help of tools like Azure Monitor. And in Azure Monitor, how do we integrate Prometheus monitoring solutions so that we can have a better way of monitoring. Prometheus is an open source solution, so we would be learning a bit about it as well. And the configuration part, where in which file, what do we change and how it works together hand in hand, that we would be learning. And end of the session, if you have any questions, we would address that. To start with, let's understand AKS cluster, which we have, out of which the master node, which is the control plane on the left hand side of the screen which you're seeing, that node is managed by Azure. So that is not visible to us, neither the processes or the system processes which are running on that particular node is visible to us. On the right hand side, which you see is called as customer managed, those are the worker nodes. They are designated as first worker nodes, and they are the ones which actually host the actual application workload. We are already seeing a set of processes being denoted over here, like API server is there on the master side, which handles the API calls which we make. Rather, it could be via the dashboard, it could be via the CLI command, or it could be via some other application like a CI/CD pipeline. Then we have a scheduler, because when we are talking about containers, and containers are not that as stable as virtual machines, they are born to die, as people say. So when we have a bunch of containers, we can't confine ourselves to a single host machine. And that is when Kubernetes comes as a rescue for the containers. When we have a bunch of containers to run on several set of servers, we have Kubernetes solution making sure that whatever is a desired state configured by us for any of the application, Kubernetes would maintain that. But when we have several set of nodes, as you can see, I have 2 set of nodes here, some decision has to be made to decide if you are planning to host a container of application, on which node would it get scheduled. So scheduler does that. HCD is the complete memory, or you can say the configuration map of the entire cluster. You have controller manager, which is like the brainy block inside the control plane, which takes the responsibility of managing the entire cluster in desired state. On the right-hand side, on the worker nodes, we would have a kubelet, which is like running as an agent. You see, that's the one which is actually getting messages from the master node. Container runtime, we are using Docker in case of AKS cluster, which has the ability to create containers. So containers would be created by Docker and managed by our Kubernetes. kubeproxy stitches up the data plane path for the application container. So in case of Kubernetes, we normally don't host application workloads on master. We only host the application workloads on the worker nodes in the cluster. Now, when we have several application containers running in the cluster, it would be very difficult for me to monitor or have a proper status check of all the things which is happening. So normally what we do, let me take you to my cluster, and I have a cluster configured. I have configured a Azure CLI in my laptop. This is my laptop's terminal, Max terminal, and kubectl get nodes would show me the number of nodes I have configured in this cluster. I have a 2-node cluster ready. And if I want to check what all resources are running in my system namespace, I can even do that with hyphen and cube hyphen system. I have to specify the namespace, and then I say which namespace. So Kubernetes system processes, which we saw just now, they are running in kube system namespace. So you would see few.
Sorry to
Is there?
interrupt. Will it be possible for you to zoom a bit?
Yeah, certainly.
Thanks.
Now it's fine.
Yes, yes. Thank you.
Okay, cool. So here there are some networking containers which are running, which help us to stitch up the networking, because when we have multiple nodes in the cluster, they need to communicate on the same network. So it stitches up a flat networking for the entire cluster. I have DNS containers running, which help us in doing the DNS resolution of the application workload, which is actually running in the cluster. We have the kube proxies running, one in each node. This one is you can think it is like an inbuilt metrics monitoring solution, which helps us to monitor a set of things. So kubectl top nodes, if I can find some set of data about the memory and the CPU utilization. It shows me how much of bytes of memory utilization is there. The percentage is given over here. Same way on the pod level as well, I can find out the details. So metric server is not that good. Why? Because it is an in-memory monitoring solution. What do you mean by in-memory monitoring solution? If I have a container running of metrics, if you can see here, there is a container, the pod running of metrics, and it is running on one of the nodes in the cluster. Let's see on which node it is running. So here with -o wide, the wider option, you can find on which node exactly it is running. It is running on the first worker node. And this worker node has a metric server running. It's not that it is only collecting data about that particular worker node. Let's understand how it collects that information. So if I have two worker nodes and I have two worker nodes like this, and I have metric server running in one of the nodes in the cluster, it is not that it would be collecting data only for that particular node. Metric server is running as a pod in this particular node in the cluster in a highly available way. In every node, we have understood that there is a kubelet which is running. So every node is having kubelet. Kubelet has an inbuilt component inside it called a C advisor. And here as well, you would have a C advisor. C advisor's work is whatever containers are running in a particular node in the cluster, which are wrapped up by pod in the world of Kubernetes, it would grab the matrices about those pod and it will have it for itself. So this guy's responsibility is to collect the data, and this guy's responsibility is to collect the data for this particular node. Metric server grabs the information from this and is showing us the data. So if I have 10 nodes in the cluster, it will show me the data about all the nodes in the cluster. And that's the reason if I do kubectl top nodes, it is showing me data about both the nodes in the cluster. It's not showing me the data about master node because master is not in our control. It is a managed Kubernetes service, AKS. So we don't see any information about the master node. This data would get lost in case the metric server pod goes down and comes up. It has to recollect the data and have the data again populated for itself because it is an in-memory database and it doesn't have that data which is present with it in a persistent storage. So in case of containers, we have some set of drawbacks like it can't persist its IP address, it can't persist its data. The read-write layer inside the container is ephemeral in nature. So normally we mount a volume inside the container so that we can persist the data which is residing in the container. So here, if we are using an empty directory type of solution, my data inside the metric server would not be persistent. So what we do, when we are creating an AKS cluster on the portal itself, let me quickly go to the portal. So this is my portal. I have set up two clusters. And in this cluster, and in fact, in both the clusters, I have enabled Monitor, Azure Monitor, during the creation of the cluster itself. Let me quickly show you how do we do that. So if I type Kubernetes here, or here, if you have recently used, you type Kubernetes here, you would find the first option which comes is Kubernetes services. If you click on add and say add Kubernetes cluster, I'm creating a new one. In this, you can choose an existing resource group. Let me quickly choose this. Give any name to the cluster. My intention is to show here integration section. Do you see this? Azure Monitor. Azure Monitor gets integrated. There are a few additional services which can be integrated with AKS cluster, and one of it is the container registry and another is the Azure Monitor. So here you can say that I want to enable the monitoring, and you can select a log analytics workspace. In case a workspace is existing, you can choose that, or you wish you can create one. So this way, while creating the cluster, I have chosen enablement for the container monitoring, and I have chosen a log analytics workspace. Let me take you back to my Kubernetes services. I'm just saving the data which I had entered. So here, if you look in this AKS demo cluster, I have monitoring section, and in that there is an insight which is showing up the data about the cluster. This data is available via Azure Monitor to us. It shows the node CPU utilization, the memory utilization, the node count, active number of pods which are running inside the cluster. All data is visible over here itself. How many are running, how many are pending, what's the status of the pods, how many succeeded, how many failed. Many a times when we are running a pod as part of a job, then in such cases, my pod status can be either a success or a failure. So in such cases, we can have this parameter also getting populated. So this information is like a permanent information. I would not lose it because it is not that it doesn't have a persistent storage, right? This is a persistent data which is available for me, and I can anywhere come and check the data here. So here cluster level data is there. If you see, I have node level data also. Here you can choose the matrices which you want to select, and you can choose the node about which you want to get the data. Here it would give entire data about it. What is running on whichever node, it would show you the percentage of utilization of it. How many containers of it is running, that is also shown over here. How long it has been up and all other information. Same way, controllers also can be viewed. Containers can be viewed separately. These are the controllers which are running. So what happens? If I just deploy a kind pod, my application can't be guaranteed to run at every point in time. And if I don't have a controller associated to my application, there's no one who is sitting and monitoring and making the self-healing, like recreation. If my application pod goes down, to recreate that pod, that action is not taken. So these are the set of controllers which actually take that action. So we are getting data about them as well. And per container data is also here. Deployment is in preview. Deployments can be viewed from here. So you have good amount of varied varieties of information over here. Which deployment is having how many containers inside it, how many pods inside it, what's the state of them, are they in ready state, are they not in ready state, are they available to be served the traffic. All those status can be seen here, and here it specifies the namespace as well. In my cluster, I just have two namespaces. If you do kubectl get pods and try to look the pods which are running in the default namespace, you would find that I have run front-end application. There is a Redis master and a Redis slave combination. I've run this, and there is a Nginx deployment also running. So there are two different websites running. There is a guestbook PHP based application backed up by a Redis master and a slave that is running. And there is a Nginx deployment, which just says welcome to Nginx type of dummy type of code, which is running in that. So these are the applications which are running. In case I scale my application to a level that my cluster is unable to accommodate that, you would get some set of errors. I'll try to scale it now, but it could be a possibility that it doesn't reflect the data instantaneously over there. So what I'll do, I would show you the failure scenario in my other cluster. I've made the failure to happen, and I have already configured that, so I can show you in that cluster as well. So I've scaled the number of replicas to be 50. Let's see whether my cluster is able to accommodate that. Few are in container creating state. These guys have gone to pending state. So there is an issue. There is a lack of resource in the cluster. My containers or the pod which are coming up, they can't be accommodated because I don't have that much of resource. Then it will go to pending state. Let me scale a bit more, say 200. Then for sure it would be going to pending state. Okay, so let's wait for a while and see if our data, which is there, that would be showing up. I have other matrices as well. You can find the metrics section here. And here you can select what type of matrices you want to see. You want to see container matrices, what type of matrices, CPU exceeding percentage, memory related information. You want to see data with respect to persistent volumes, which are there in the cluster, or on the node level, you want to have an insight. It would show you all the data. So if I'll go and see the CPU usage in millicores, you would see that suddenly it has started to increase. And at one point in time, it was too high. It was at 7:52 a.m. when I was like trying to keep everything ready for this demo. You can see that it has hit too high. So this particular setup looks so beautiful and it is integrated so quick. I just need to select a radio button and provide a log analytics workspace. And the all set of data starts to get captured. But in case I want to do Prometheus scraping and I want Prometheus way of monitoring my solution, then it becomes more troublesome activity, right? Normally what we do, if I have a Prometheus monitoring solution to be deployed in my cluster, I would be actually going to, let me skip a few things in my slide and show you the Prometheus one. So I would need to have Helm charts placed. I would need to have some operators created, some custom resource definitions created. And at the end, with the help of Prometheus and Grafana, I would be able to visualize the complete data or the monitoring data from my cluster. So I have done that as well. Just let me quickly take you to the Grafana dashboard. Here, there is another cluster running whose data is showing up in this Grafana dashboard, the second cluster which was running. So this is the cluster which is not in that good state at this point in time. Already things are in pending state. So our resources have hit a limit in that case. So if I go to monitor task, I can show you there as well. You can see the data in monitor here. And you would find that I would say visualize. Let me go to the container section. And here we can click on this view monitored cluster. Can you see this? Critical is there, total is there, warning is there, unknown is there. One guy is showing critical, and that critical cluster is this. In a while, you would start seeing this as also critical. I am having these many 223 pods, out of which 206 pods are in trouble. Here on the Azure Monitor dashboard itself, it clearly states that one cluster is having a critical status, one cluster is having a warning status, number of nodes which are there in the cluster, number of user pods which are hosted on that cluster, and number of the system pods. If I don't take an action, in a while, this warning will also convert into critical status. So here you can visualize from here itself. That gives us a good visibility. If I click on this and get inside the cluster, I can see that in the monitoring section, how we saw. So this is for the other cluster. How do you configure this Prometheus? When I have to run Prometheus, it's like an open source metric solution which is there, right? It is part of Cloud Native Computing Foundation. I need to deploy my Prometheus servers in that, and it's not an easy task. Let me show you my resource name. I'll set my apply to get into the other cluster. AKS-cluster1 is the name of my cluster. I think the name is resource group is that. Let me check quickly. AKS cluster 2, and I'm looking for one. That's so foolish of me. Okay. So yes, now if I do kubectl get nodes, I'm talking to my other node, other cluster. It would just have one node in the cluster. So I've switched my cluster context for my kubectl. And if I do kubectl get pods -n cube-system, you will get terrified now. Why? Because you would have a lot of resources running like this. This is the general one. But if you see here, if I just do get bots, I have the Prometheus ones also running. Can you see this? This Prometheus ones are the one which will help me to run the Grafana dashboard and the Prometheus alert manager and all that. So I am maintaining 1, 2, 3, 4, 5, and 6 pods to actually serve the Prometheus monitoring. But if I say you that if you have Azure Monitor, you have to do nothing to do that, how cool that would be, right? I don't have to host a separate Prometheus server to get the Prometheus monitoring done. With Azure Monitor, it's pretty easy. Let me quickly go to my, there is a configuration map file which I apply to my agent which is running. This is a configuration map file for Prometheus data collection settings. And in this, you just need to say that I need to monitor my pods. I've set that flag to true and few other stuffs. From which URLs you want to collect the matrices and from which namespaces you want to collect the Prometheus matrices. It will start to do Prometheus scraping, grab the data and show that to you. So this configuration, when you do, you can even add some annotations to your pod definition and you can have them configured for it. If I have, okay, so let me switch my cluster context. I'll show you. I've configured that. So in this cluster, in cluster 2, I have manually configured Prometheus and have a Grafana dashboard, which is serving from here. But in case of the other cluster, the AKS demo, I'm entirely using Azure Monitors functionalities and I've enabled Prometheus scraping and I'm able to collect Prometheus data from there. So if you go to matrices, I'll go to the logs. In the log section, I can run a query and show you that I'm collecting matrices from this. Let me run this query once more. You would find that a lot of data would get configured. This Prometheus is grabbing all these information from my cluster. And it did that only because I have enabled that particular Prometheus scraping in my cluster. So if I do kubectl get pods, and I have my Nginx, so kubectl, yep, these pods which are running in this cluster, they are being enabled for Prometheus scraping. And how did I do that? I had specified in my file that I want to do Prometheus scraping for my entire resources or type of applications which are running in my default namespace. And that is how this data is captured. So Prometheus can be enabled with Azure Monitor. It can be integrated so well with Azure Monitor that you would not realize the pain of it. Let me take you to my slide. Here in this diagram, it makes it pretty clear. I have the node. I can have a node exporter, and from there, I can push in the data to my log analytics agent. This agent is running in every node in the cluster, and that grabs the data and pushes that to your Azure Monitor. Here, pod level information can be collected. You can add this annotation that you want to have the scraping. You collect your matrices, the port number, and the type. All those things can be added to each of the pods. So when you are defining your YAML file. In that itself, if you add the annotation, that would be like how many ever replicas you're creating, it would get added to all of them. Now, service level monitoring also can be done. The endpoints which the Kubernetes service which we create, you can add them like this in the same config map file and apply those changes. Your OM agent, which is running in every node in the cluster, that will help us to grab that information. So I'm almost done. I just want to show you that OM agent, which is actually helping us do this. Here, if I do kube-system, we should see this OMS agent. This is what I was talking about. These are the guys which are actually configured now to do the Prometheus scraping. I have applied that config map so that it can pick up the data from each of the pods which are residing in default namespace. If I have any other namespace, my Prometheus scraping will not be done for them. I need to manually go and change the configuration map and apply the changes again. So instead of deploying Prometheus server, Grafana dashboard separately or having different logging and monitoring solution, we can look for a central solution like Azure Monitor and have Prometheus scraping enabled for it. That gives us a better perspective or better solution for managing our entire cluster. And in this view, you can see that on Monitor web page, you have both the clusters visible. It's just not one cluster. If my cluster is running in AKS, my cluster is running in Azure Stack, my cluster is using AKS engine to deploy, or my cluster is running in on-prem, Azure Monitor can support any type of deployment of Kubernetes. And that's one of the beautiful services provided by Microsoft, which can be like widely used to monitor our entire cluster, whichever environment it is in. So here you can switch the environment and you can have a view. Azure Stack and non-Azures are in preview stage now, but very soon they would be also in full-fledged features would be enabled in that. So that was all from my side.